6 days and 17 hours. Funnily enough, here he goes for world record attempt 6:18, and he's done it.
Pole vaulting is more complex than you think, so let's break it down. The main component of the physics of pole vaulting has to be kinetic energy. The vaulter aims to have greater kinetic energy. This greater kinetic energy will then be able to convert to a greater gravitational potential energy. The kinetic energy formed is 0 at the top. This is at the maximum height of the pole vaulter. This is because all the energy is converted into potential energy. Keep in mind this is the perfect situation, and realistically some energy will be lost during the conversion. The pole shown here is instrumental in converting the kinetic energy into potential. Now let's look at the pole vaulter we watched in the beginning. The maximum height represents the center of gravity. This would be around his stomach area as he clears the pole. Now taking everything into consideration, we can set the potential energy and the kinetic energy equal to each other as shown here. This equation can be simplified. The mass can be cancelled out on both sides of the equation. This shows that the mass does not play a factor when considering the height in the equation, but it does play a factor when considering just the kinetic energy. Now we were trying to solve for the highest possible height, so now we're bringing the h alone on one side of the equation. From this equation, we can conclude that the main factors in determining the height is gravity and velocity. Now let's do some example problems in order to prove this. Here we have two different vaulters with different velocities. The pole vault will be set to 1 meter in this situation. The first vaulter has a velocity of 5 meters per second, and then the gravity is 9.8 meters per second because we're on Earth, and then the height is unknown. So we use the equation, which is 1/2 v squared over g equals the height, and then plugging in the numbers that we have, we are given a max height of 1.28 meters per second, which is enough to clear the 1 meter pole vault. That vaulter cleared because they ran with a greater velocity, which translated to a bigger kinetic energy and a greater potential. Now we have our second pole vaulter running at speed of 3.5 meters per second. Then we have gravity is 9.8 meters per second, and then we have to find the height. So using the equation here, we plug all the numbers in, and then we are given a height of 0.625 meters as the max height. So this is not enough to clear the 1.0 meter pole vault. This vaulter did not clear the bar because they did not have a great enough velocity and therefore did not have enough kinetic energy. As just shown here, the pole vaulter can also bend their body around the pole to maximize their maximum height. By doing this, they can clear the bar even though their center of mass is below the bar. Keep in mind there are some flaws when using this equation to calculate the maximum height. The first flaw would be that we are assuming that there is no air resistance in the pole vault. Air resistance can result in the vaulter not reaching as high as a height as calculated. Another would be that there is still some velocity occurring when the vaulter goes over the pole. There is a horizontal velocity as they are still moving in that one direction. So due to this kinetic energy, it wouldn't be 0 at the top exactly. This only causes a slight decrease in the height calculated. We are also assuming no energy is lost during the vault, which is not the case. An example of some energy being lost is when the vaulter plants the pole in the box before lifting off. Overall, there's many factors that affect the pole vault, but velocity is the main one. Thanks for watching.